So I'm going to talk about...
I'm going to talk about serverless.
which some of you might have heard of. Hello?
You can shout if you want.
I'll just shout. Move to the left. That.
Is that better? Can you see me at the back? Right, good. Okay, I'm going to talk about serverless, which some of you might have heard of, I hope. And it's the future, which is a very exciting thing and something a bit disruptive, which is, I believe, the theme for this evening.
What's happening? And I'll try to explain a bit about what serverless is and why it's taking over.
Is this working? Yeah, sort of. So,
something you might have... This is really interrupting me. So, something you might have seen is that software is eating the world. Mark Andreessen said that maybe 10 years ago. And it's a really famous saying of his. In the kind of application delivery space, it's happening both to hardware and at the very front end. Once upon a time, browsers just played HTML, there was no JavaScript, there was no nothing. And hardware was just hardware, right? It was just tin you put in a rack. But over time, software and the sort of disciplines around software have started expanding, both into the front end, where you get JavaScript and all sorts of other cool stuff down, and then into hardware, where you get things like DevOps and cloud and that sort of thing. Now, these sort of initiatives, the way software has moved into DevOps and then public cloud, which is really just software versions of hardware, is moving on now to a thing called serverless, which is kind of an architectural pattern, a way of designing your applications. Now, to understand why that might be interesting, have a look at what architectures used to look like. And this is about the last 40 years worth of systems architecture. That was 1970s, two-tier, 1980s, three-tier, 1990s, software-oriented architectures, and then a load of enterprise service buses and stuff like that. So that's the last 40 years, pretty much. Now, that kind of worked. The problem was, you couldn't scale them. And it's a really, really big problem, this. If you've ever been there, you build an application, it kind of works, and then you go, oh my god, I've got to support 1 million users, and it doesn't work. It really doesn't. If you're going to build something for scale, you need a completely different architecture. One that is very different from those really simple, bog-standard ones that you read in a book. Getting the features right is really hard and really expensive. But making it scale is even harder. Really, really hard, in fact. Real-world web-scale systems like Twitter or Facebook and really big systems like that, they have Byzantine architecture. They do not look like something out of the book. And in particular, those architectures depend upon very specific characteristics of the application that you're building. So you might remember Twitter promised maybe a year ago they were going to be bigger than 140 character tweets, right? It's not happened. I don't know, but my guess is their entire architecture depends on tweets being really small, right? And it's not a very stupid thing to make your architecture dependent on, but it's Twitter, right? The tweets are small, that's how that works, yeah? And that's what I mean by Byzantine. You would never think, oh, we can't scale our system because we want to make tweets 200 characters. So, this is my personal experience of when you have an application that needs to scale. You build version 1, it's kind of alright, you spend some money, because this is kind of money effectively, and then you go to version 2 and you spend some more, and then they start making money, right? You've got users, you've got some subscriptions and shit going on. And then they go, this is it, brilliant, we can spend loads of marketing money, we can scale, and I have to say, sorry, I need a couple of million quid, 8 months or something, and we need to build version 3. Everybody hates that, right? You've got a VC, your VC is already really sick of you by here, right? You start making some money, he's very happy, then you've got to go back and get 3 times as much. Nobody likes this conversation, right? So, serverless. The idea of serverless is you basically just have sort of a big bag of functions up in the cloud, right? It's not your problem to operate it. You upload them, they run, you don't have any computers, hence the name serverless, right? Although obviously there are servers. And you have mobile applications on single page apps. And the dream, really, is that you build your features out, and then when you need to scale, you just do a little bit of twiddling, bit of testing, and off you go, right? Now, for many people, if any of you are startups or working with startups, everyone who's got a startup, they want to be the next bloody Facebook, right? They want to be the next Uber. And to be the next Uber or Facebook, you need to be on here, right? Obviously, most startups die about there, but, you know, you've got to hope. So, the problem with serverless is latency. And this is the actual latency in a web request, right? You've got to buy a computer, you've got to put it in a rack, you've got to install the operating system, you've got to install the app, configure it, do all sorts of other stuff, and then finally you serve a request, right? Latency for your first web request is about 2 weeks. For between starting and finishing, right? But the one after that is maybe 200 milliseconds. So the next one is quite quick, right? And what you've done really, you've gone through all this grief, purchasing dedicated resources so that you can reserve your future latency, right? That's your computer that's sat there now, ready to serve people, so that each request can be really fast, okay? Serverless, you're not doing that. You're just hoofing your functions up into the cloud and hoping they get run. I remember reading this somewhere. People claim an abacus is faster than a calculator, but that's only if you ignore the 3 years it takes to learn how to use an abacus. It's a similar sort of thing. So, with serverless, you've got a problem, potentially, with latency. And I'll try and explain the trade-off. So, you're on the shared everything model. And this is something like Lambda at AWS, where they've got a whole load of computers running the functions you load up there, right? You don't know how many computers your functions are installed on. That's entirely their problem. And you're sharing those computers with other people. And you may have experienced this if you've done stuff in public cloud before, that because you're sharing those resources, you have much less control over them, right? There you go, you have less control over your latency. And sometimes your latency is good, and sometimes it really is quite good, but sometimes it's bad. And in particular, the times when you really need it to be good, which is maybe you've got a whole load of users turning up, is particularly the times when it's bad. Now, once upon a time, you haven't seen a graph like that, acceptable page loading times, right? Any of you who are in marketing, particularly in web marketing, will know this graph, that users drop off a web service really, really fast as it gets slower, right? If your page loads in 2 seconds, you lose 10% of your users because they're already bored, right? You take 4 seconds, you're nearly at 25%. 10 seconds, half your users have gone before the page is loaded, right? Amazon spend a fortune trying to get their website faster, right? But you can imagine, you don't own a computer, you aren't controlling how fast your things are, you might end up here, right? Which is a disaster. So why is it acceptable? Because clearly from that graph, there's no way it should be acceptable to lose control over the latency of your service, right? Well, that just says the same thing. The reason is mobile. And if you're working in this business, you'll know mobile has completely changed the way that people are using the internet. And there's some sort of accidental side effects of that kind of changed our assumptions of what an application needs to look like on the internet. So, if you've got an expensive client network, which you do on a mobile phone, if you're like out and about, but you've got cheap storage, it pushes you towards an economic decision to download everything in advance, right? And the same applies if you've got high bandwidth but high latency, which is often the case on mobile as well. You download an app all in one go at the beginning, and then you use it while you're out and about, okay? Completely different from wired computers that you might have had 10 or 15 years ago. Now, what that means you get with a mobile application is you download it at once, right? You need a fast client device, which we never used to have, and good storage. And then you can have a low latency user interface. Somebody clicks a link, you can respond immediately because your application is running locally. It's not like websites of the past where every time you click a link, it's got to go all the way back to the server and download a new page, right? So no longer does our this graph apply, right? You can respond instantly, and that's what you get used to with mobile applications. That even in areas of like poor network reception, that kind of thing, they tend to be relatively responsive, and they can manage the way that latency is handled. So, there's a final piece of the puzzle as to why serverless can now work, and that is anonymous clip art child. It's a single page application. And this is something that's emerged very recently. So, these are called SPAs, and some of you may have heard of them, you might even be building them. You don't really have pages in a single page web application. You just download a great big lump of JavaScript. It's basically like a mobile app that runs in a browser, and there's some technologies out now like ES6 and React and Redux and CSS modules that mean that it's almost not awful to build these things. It used to be really, really awful, but it's almost not bad now. With a single page application, you download the entire application initially. You need a fast client device, you need good storage, but you render everything locally. If you imagine, because your application downloads straight away, but then you can access your application like endpoints whenever you like, you can cope with the variable latency that you get from a serverless application. So you can accommodate that variable latency. That means that an application built in the serverless style, you build a great big JavaScript app that you ship out in the browser, you build a mobile version that goes up to phone, and then you don't have any servers at all. The whole app gets downloaded in one go, and you access your endpoints in the cloud. It's actually pretty good. We're building them now, and it's a really nice way of working. There are some disadvantages. Price. You must be doing stuff in public cloud. If you can ever work out how much you're going to spend, you're doing better than me. I've never got any idea what something will cost. Operability, things, logs. Logging is absolute shite. It's awful. It's really hard when you have a bug to work out what's going on. Release management, upgrades, that stuff, it's all a bit rubbish. The platforms are really unstable in that they're changing a lot. In particular, the tooling around the platforms is changing really, really rapidly. Availability. If you're running a really, really crucial platform, you know, you're doing play-along games for TV or something, you really care about your availability, you've got no control. So it's Amazon, it's probably going to work, but if it breaks, there's nothing you can do. And finally, strategic alignment is always a big fear when you outsource something critical, because who knows what your suppliers want to do, right? If Amazon suddenly decide they're joining Elon Musk and going to Mars, then you might be stuffed. So if you want to try some of this stuff out, these are some of the technologies that are floating around out there. Firebase is great, it's really good to get started with. React and Redux seem to be taking over the world as far as the single page apps go, and they're pretty good as well, actually. Lambda is by far and away the most common kind of functions as a service thing, but OpenWhisk is an interesting alternative. Okay, thank you, everyone. We've got a white paper that's just come out about chatbots. If you're interested in chatbots, you can come and speak to us. We'll give you a URL. And thank you very much.